Okay, in this video, I'll be showcasing three methods for triangle area. The first method is base times height divided by 2. So I'm sure you've seen this thing in middle school where we have 5 here, 10 here. Okay, that's the area of a rectangle, right? If we want the area of a triangle here, we just split it in half. So we do 5 times 10 divided by 2 for triangle area. So this would be 25. Okay. So we have triangles and they give us the length of this base and this perpendicular height, then we could find the area pretty easily because then it's just base times height divided by 2. But let's try it for this problem. The area of a certain triangle is 150 units. If the height is 5 units less than the base's length, find both the length of the base and the height. Okay, so let's write what we know. We know that base times height divided by 2 is going to be equal to area, so that's 150. Okay, what we're going to do next is, since we know that the height is 5 units less than the base's length, we can write that as b times b minus 5 divided by 2 is equal to 150. B times b minus 5 is equal to 300. And at this point, you would either use the quadratic formula factoring. I'll graph this. So x times x minus 5 is equal to 300. And I get that b is equal to 20. Okay, b is equal to 20. And if the height is 5 less, that means the height is 15. Okay. However, we aren't always given the height so easily. And sometimes we have to find it ourselves using the sine function. Okay, now on to method 2, which is this weird formula. I wonder what this does. Okay, find the area of a triangle with two side lengths of 3 and 4 and an included angle of 30 degrees in between. Okay, this vocabulary, included angle, let's label this real quick. The included angle is just going to be this angle in between. Okay, 30. Okay, and there's no height, so let's draw one. Let's call it x. Okay. And so we can have a right triangle from this. Trace this out. Okay. So we get a right triangle with a hypotenuse of 3 and this angle of 30, and we want to find x. Okay, well, you may recall from trigonometry that if we have it opposite, since this is opposite to the angle, and the hypotenuse, we can use sine. So we have sine of 30 is equal to over h, stock of TOA. So it's equal to x over 3. And evaluating sine of 30, just because you know it, or using a calculator, you get 1/2 is equal to x over 3. Multiply both sides by 3, and you get that x is equal to 3/2. Okay, and since x is our height, we just put that in now. 3/2. Okay, and now we can use the base times height we know and love. Okay, so we have this whole base of 4 and a height of 3/2. So 4 times 3 divided by 2, which is 1.5 by 2. So it's going to be 4 times 1.5, which is 6, divided by 3, is equal to 3. So the answer there is 3. Okay, now for the third method, which is, okay, what is the area of a triangle with side lengths 4, 7, and 5? Okay, So the formula says area is equal to, we're gonna have a long radical, it's gonna have a nice pattern. S times S minus A times S minus B times S minus C. Okay, and you might ask, what's this S? Okay, well, S stands for semi-perimeter. And breaking it down, if you have a semi-sphere, that's half of a sphere. So semi-perimeter is half the perimeter. Okay, and the perimeter is going to be 4 plus 7, 11 plus 5, so 16. So 16 divided by 2 is S. And then the A, the B, and the C are just those individual side lengths. Okay, let me complete this 8. Okay, so now let's just all plug it in. 8 times 8 minus 4 times 8 minus 7 times 8 minus 5. Okay, we have 8 times 4 times 1 times 3. Okay, and this one's redundant. We can get rid of it. I would break down this 8 like this. 4 times 2 times 4 times 3. And the reason I broke it down into 4s is because now we can get it out of this radical and write it as square root of 4 times the square root of 2, square root of 4, square root of 3. These 4s is should be 2 times 2, so 4, 4 root 2, root 3, so 4 root 6 is our answer.